Hi friends, what about this library? How is it? It's very nice, isn't it? Many books, many shelves, very big library hall. So most of the people nowadays is not reading anything, isn't it? Because of mobile phone is replaced this book reading, I think. But whatever it is very nice place, isn't it? If you are sitting in a library in a calm area and reading the book, isn't it? So here we know that all these books are arranged in a very good manner. Okay, means some of the shelf Malayalam novels are arranged, another one English novels, and another one English short stories. Okay, so such a way it is arranged. Okay. Very good arrangement. What I am asking is, what about this arrangement? Is it need? Yes, it is need, isn't it? It's necessary because to choose a book easily from the library, actually that arrangement is required. It's not only in supermarket also you will notice that snacks are in particular area, vegetables are in particular area, isn't it? And other items, okay, soap, paste, etc., isn't it? So every items they are arranged in different area. For what? As we can easily select, isn't it? If we are going that the area that which arranged these snacks, so we can easily select the snack which we need. Okay. So such a way it is arranged. So this arrangement is very important. Okay, arrangement is very important. So that will help us to choose the things. Okay, and also we can compare, and also we can learn, etc. That is possible. In all the cases, we arranged many things. So whatever it is, the same arrangement is there in the case of elements. Elements also arranged. Okay, actually, it was started many years back. Do you know who is arranged first these elements? That is Antonio Lavoisier. Okay. He was the first person arranged these elements, classified these elements into two, that is metal and non-metal. That was the first arrangement. The elements which is showing similar chemical properties, that means similar chemical properties to metals, all that are metals. Which is not showing such characters, that is non-metal. That was the first classification, metals and non-metals. Clear? So after that, the person Johann Wolfgang Dobereiner. He arranged elements according to their properties and in the increasing order of atomic mass. That is known as he arranged and made some groups. Okay. So he selected three elements which are showing similar properties. So he chose three elements which are showing similar chemical properties, and he arranged the three elements in the increasing order of atomic mass. Okay, and he considered it is a group of three elements which showing similar property. So we can easily study about these three elements, isn't it? Because all these three elements are showing similar chemical property and physical properties also. Is it clear? So that we can easily learn about these three elements. Okay. So that is so he identified such a way. That's why it is known as triad. Tri means what? Three, because he identified these three elements are showing similar chemical properties. So such a way he got three groups. In each group there are three elements. Which are showing similar chemical properties. Okay, what is his name? Johann Wolfgang Dobereiner. So that is known as triad. So according to his classification, his arrangement is done by in the increasing order of atomic mass. So first he written which one has lowest atomic mass. Next higher atomic mass, next higher atomic mass, such a way. So that means in the increasing order of atomic mass. So he arranged these elements. Example, first one is lithium, second one is sodium, third one is potassium. Lithium atom mass is 7, sodium atom mass is 23, potassium atom mass is 39. So it is in the increasing order of atomic mass. So lithium, sodium, potassium, that is his first triad. Then he again searched and he identified one more triad, that is calcium, strontium, barium. Calcium, strontium, barium. So that is also in the increasing order of atomic mass. Clear? Then third one, that is chlorine, bromine, iodine. So that is also showing similar properties. We know that these are halogens, isn't it? So these are showing similar chemical properties and physical properties, and it is also in the increasing order of atomic mass: chlorine, bromine, iodine. So these are the three triad. And what are the properties of his arrangement? One is he could able to identify these three elements which are showing similar chemical properties. So he arranged in the increasing order of atomic mass. Then one more thing is the very interesting thing is the in his arrangement. See that lithium, sodium, potassium. What is the atomic mass of lithium? 7. What is the atomic mass of potassium? 39. So add 39 plus 7 and divide with 2. Yes, you will get 23. So that means the average of first element and third element, the average atomic mass of first element and third element will show the atomic mass of middle element. Okay, so that means atomic mass of lithium plus atomic mass of potassium divided by 2, which is equal to 23. That means it is the mass of sodium. Okay, so other case also like that, calcium, strontium, barium. That also if you add, you will get almost similar to the atomic mass of strontium. And chlorine, bromine, iodine. If you are adding atomic mass of chlorine plus atomic mass of iodine, you will get and after you want to divide with 2, so you will get the atomic mass of bromine. So that is a Dobereiner triad. Okay. So what is his disadvantage? It's a disadvantage. He identified only the elements, only 3 elements which are showing similar chemical properties. Actually, there are more than 3 elements are there which are showing similar chemical properties. Okay, so that is one of the disadvantage. And another one is he able to made only these 3 triads. Okay, that means he is able to identify more than these 3 triad. Okay, but according to his properties and his classification, in that case he identified and he made only these 3 triad. Okay, so that is another disadvantage. So that is known as Dobereiner triad. Okay, that we consider as the first periodic table. Okay, then so this is what actually this is a history of this periodic table. In modern periodic table, we know that there are many groups and many periods and etc. Very big one, isn't it? And there are a lot of elements also. Okay, more than 100 elements are there. Okay, but here only very less elements because that time only discovered very few elements. Okay, so on that basis, this is one of the first classification done by the person Johann Wolfgang Dobereiner. So that is known as Dobereiner's triad. Okay. So okay students, I hope all of you understood this concept, Dobereiner triad. Thank you students.